Good morning all of you. Today we are going to start a new experiment, that is Newton's law of cooling. So in this particular experiment, this is the longer experiment we are having. So in this experiment we are going to study the relationship between the hot body temperature and the time. So let's start this experiment. The aim is to study the relationship between temperature of hot body and time by plotting the cooling curve. So in this particular experiment, we are drawing the three number of graphs, and after that plotting all the graphs, we can conclude some things. So Newton's law of cooling is just a simple law that stated this rate of fall of temperature is directly proportional to the axis of temperature. Now this d theta by dt can be called as the rate of fall of temperature, and theta minus theta 0 is the axis of temperature. Now one by one we will go to see what is meant by theta, what is meant by theta 0 and how to calculate it. Okay, so let's see the apparatus what we are going to use in this experiment. One calorimeter we will need. Okay, so calorimeter is nothing but the double walled insulated box. It is made up of wooden. This is the simple arrangement of calorimeter. Inside this calorimeter we'll put one insulated material over here, so that the inside heat will not go outside. Okay, this is the insulation for the particular system from surrounding. So this is the insulated double walled calorimeter. One stand is provided to hold the thermometer. So this is the thermometer we are having. Now this thermometer is having least count of 1 degree Celsius. So this is just simply a thermometer. Now we are using the digital stop clock. Okay, so this is the stop clock we are going to use for the measurement of time. Now this is one beaker with stirrer. Inside that I have poured some liquid, and this liquid should be hot enough to take readings. So this is now this water is cool, it is not hot. This is the stirrer to use for the sterilization. Now this is the arrangement. We need to put it inside the box. In this way, I just keep this vessel inside the box, surrounded this insulated material. Okay, so now this water will be heated for taking readings. Now this water should be above 100 degrees Celsius. So boiling water, in short, we need to take it in this vessel. We'll put it after heating in this, and we'll keep one lid so that the exchange of heat will not take place over here. So this is one lid. Now this stirrer will go in this way. This is the thermometer. Just make sure this thermometer end should not touch to the vessel bottom or stirrer. So now this is the thermometer, and this is the stirrer end. Now this whole instrument is ready for taking readings. So this is about the apparatus. This is the heater. Will provide you the boiling water. Okay, so this is simply a coffee heater used for the heating purpose. Now we need to understand what is the formula for Newton's law of cooling. Now in this we are going to see the two important quantities, axis of temperature and rate of fall of temperature. You can also say rate of change of temperature. So theta is the temperature of hot body. In our case, the hot body is water. So we are going to measure the temperature of hot body which is present in this vessel. Okay. So d theta by dt is the rate of fall of temperature of hot body, where theta is the temperature of hot body again and theta 0 is the room temperature. So hot body temperature minus room temperature, you will get the axis of temperature. So in this way we can verify the Newton's law of cooling by taking the readings of hot body. Now this is the formula. So this is simple arrangement, experimental arrangement I just shown you. It is similar to the diagram. We are having stirrer, we are having the bench, okay. Just make sure the heat loss not should be there within the circuit. Now, if you consider the observation firstly. So least count of stopwatch. Now we are using the digital stop clock. Okay, in this you can say if you are using the analog stop clock, we will say that we are going to use the stop clock of least count 1 second. Now this least count of thermometer is 1 degree Celsius and the room temperature is just now it is 24 degree Celsius. But if you perform this experiment in summer, it will be the temperature will be like 35 degrees Celsius or 36 degrees Celsius. Okay, so this experiment is depends on the room temperature. Okay, so we need to note all the observations before starting the experiment. So we have noted all the observations. Once you're done with the observation, we'll move further to the observation table. Now this is one observation table is here. Now suppose this is the container having boiling water. Okay, in this container boiling water is there. Okay, so we'll need to place it over a tabletop, and with the help of this stop clock we'll measure the time. After every half minute we'll measure the temperature of water, which is theta, which will be in degrees Celsius. Okay, so simply you need to wait for 20 minutes. So in short, we are taking 41 readings with the help of this instrument, this experimental arrangement. So once you start the stop clock, you should be alert while taking the readings. Just after half minute, you need to record the reading. After 1 minute, you will record the reading. After 1.5 minutes, you will record the reading. So in this way, we will record all the temperature for particular half minute till 20 minutes over. So this is the first observation table. Will take 20 minutes at least. Okay, this is the simple experiment, but it will take longer time to take the readings. So this is how we will complete the observation table number 1. So let's move towards how to plot the graph number 1 with the help of observation table number 1. Now suppose you are getting the graph is like, firstly we will take into consideration the graph is in steep, and after going cooling towards cooling, when the water gets cooled down and it comes nearer to the surrounding temperature, the steepness in the graph gets reduces. So this is just, we can see here. So in this way you can see we have considered all the thetas, means the temperature of water, the boiling water on y-axis, and the time from 0 second to 20 minutes on x-axis. So in this way we will get number of points over here, and we will plot one simple graph joining all the points, and this will be the nature of graph which we get from observation table number 1. So this is just a simple graph. Now what to do? By using, we need to use this graph for finding the observation table number 2. So simply what you will do, you just note down any 5 thetas, Suppose this is the 1 theta, suppose this is 60 degrees Celsius, suppose this is 55 degrees Celsius. Now this is suppose 50 degrees Celsius. In this way you will consider only 5 theta, any 5 theta on the graph, and just circle it which 5 theta you have taken into consideration. Now this 5 theta will help us to find out the slope. Now for this, suppose for example I am taking into consideration this theta. Now this theta is 40 degree Celsius. Just suppose this is 40 degree Celsius. Now just draw one tangent. Okay, this is the tangent to this point, and we'll use this tangent to find out the slope. Now there are two ways to find out the slope. You can find out the slope by using y2 minus y1 upon x2 minus x1. This formula can be used for finding the slope. Another method to calculate the slope will be just simply you will make one triangle along this tangent and just measure AB length upon BC length, okay, in centimeter. That's why you will get the slope, that is tan phi. So this is the example for only 1 theta. Similar step you need to follow for 5 theta. Suppose you will start from this 1, 2, 3, 4 and 5. For 5 theta you will get 5 slope, that means 5 tan phi. Okay, so this is the formula for finding the slope. You can use it. Now after calculating all these things, you will get this observation table. So this first column will have the theta, the value of theta which you have taken into consideration finding out the slope. जो slope निकालने के लिए आप theta use करने वाले हो, that theta should be written over here in this column. So firstly we have taken 60 degrees Celsius. We'll write here 60 degrees Celsius. Now this 60 minus room temperature means 60 minus 24, answer will be there in this column. Now what is meant by d theta? D theta means simply this is theta 2 minus theta 1 means d theta. As you can see here, d theta is equals to theta 2 minus theta 1. So the answer you will write in this section. Now what is meant by dt? dt means this T2 minus T1. You will get this T2 minus T1 from this graph. Okay. So from this graph you will get d theta and dt, and after that you need to take the ratio. Now this ratio is simply means the slope, that is tan phi. Now this is d theta by dt means this column upon this column. Okay. So this column d theta by dt upon theta minus theta 0, answer will be here. Okay. So this is just example for one reading. Suppose I have taken into consideration 60. Okay, 60 degrees Celsius I have considered. Now 60 minus 24. After that d theta you will get from graph, and dt also you will get from graph, and this d theta, and this d theta by dt is nothing but the ratio of these two columns, this and this. Okay, this column and this column you will get this column. Okay, after that when you will get this column and this column, so d theta by dt upon theta minus theta 0 will get k over here. Now this is the value of k we will get here. So all k1, k2, k3, so k1, k2, k3, k4, k5, and we need to find out the mean k over here. You will get the mean k K here. So calculate all this table. Okay, once you done with the finding slope, after that you will take observation table number 2. See, firstly we will perform this experiment for finding the observation table number 1. मीन्स ऑब्जर्वेशन टेबल नंबर 1 के लिए ही हम ये परफॉर्म कर रहे हैं और ऑब्जर्वेशन नंबर 2 हमको कहां से मिलेगा फ्रॉम ग्राफ 1. सो वंस यू डन विद ऑब्जर्वेशन टेबल नंबर 1 you will plot the graph first, and after plotting the graph number 1 you will get the observation table number 2. Okay, after this, by calculation and by getting all the observation in table number 2, we'll move toward the graph number 2. Okay, you will get graph 2 from observation 2 only. So firstly you will need to draw the graph number 1. So this is a simple graph. We are having here d theta. Now see, y axis is having d theta by dt, 5 readings of d theta and dt on y axis, and all thetas from x axis. So theta you need to consider from here and d theta will consider from this. So with the help of these 5 readings we will get this kind of graph. Now this is the intercept. This is the intercept, and from this intercept we are able to find out the theta 0, and theta 0 is nothing but the room temperature. Suppose for this instant I am taking into consideration theta is 24. So similarly I get the theta 0 from this graph is approximately equal to 24. Okay, so 23 or 25 it will be the good answer. But if you are getting 20 degrees Celsius the room temperature, so it will be the wrong. Somewhere you are taking the wrong readings. So this is the graph number 2. We have taken this graph number 2 from observation table number 2. Now this graph number 3 also we will get from observation table number 2. So from observation table number 2 we will take 5 readings of d theta and dt, and this theta minus theta 0, which is the axis of temperature, will take from the observation number 2. Now this is the graph which will help us to find out k. Now we have already calculated k, which is the proportionality constant, by calculation. Now we will find the value of proportionality constant k with the help of graph. If this by calculation value and graph value get similar, get approximately equal, that means we have successfully done this experiment. Now this is the linear graph we are getting here. That means the rate of fall of temperature is directly proportional to the axis of temperature, which is nothing but the theta minus theta 0. So this is the graph number 3, and this is the formula to find out the graph slope. Now what you can conclude from this experiment? Firstly, the graph number 1 shows the Newton's cooling curve. क्या दिखा रहा है उसमें? Steepness पहले बहुत ज़्यादा था, but when the system gets approximately equal to the surrounding temperature. Now suppose this is the system and the atmosphere surrounding it is the surrounding atmosphere. So this is having particular temperature and the surrounding is having particular temperature. That means surrounding temperature and this temperature is having some differences. That's why this heat loss will be towards surrounding. So this is the hot body and surrounding is the cold body. So this heat will move from hot body to cold body. So this is the general idea behind this. So from first graph what we have concluded that Newton cooling curve is having steepness. When the system loses heat to the surrounding, the steepness get reduces. After that, graph 2 is a straight line graph, and from that graph we have concluded the room temperature value is nearly same which we have observed before starting the experiment. After that, from graph 3, okay, we have find out the intercept, and graph 2 is a straight line graph. This is linear graph, and from linear graph we can conclude that the rate of fall of temperature, that is d theta by dt is directly proportional to theta minus theta 0, which is called as axis of temperature. And k by calculation and a by graph, these two values should be approximately equal. Then only we can say this experiment is successfully done by you. So this is about this experiment. What precautions we need to take into consideration while performing this experiment is that this stirrer should not touch the thermometer tape, or this thermometer tape should not touch the vessel. Okay. After every 2 readings, you need to stir the water for uniform heating of water. So this is just simple precautions you need to consider while perform this experiment. So now this experiment we have done successfully. I hope you have understood all the things. Okay. So we'll send what are the readings for this particular experiment in the given link with the same video. So let's recap, take a recap what we have studied in this experiment. So we have studied the Newton's law of cooling in this session. Particularly we have studied the relationship between the temperature of hot body and time by plotting the cooling curve. For this we are having this, we have used this instruments: calorimeter, stopwatch, thermometer, stirrer, and this coffee heater for the heating purpose. Just simply. Okay, as simple as that. Then we have seen the formula: d theta by dt is directly proportional to theta minus theta 0. In this, d theta by dt, it is the rate of fall of temperature of hot body or a system. Theta 0 is the room temperature or the temperature of surrounding. Okay. And theta minus theta 0 is the axis of temperature. Simply we have seen the experimental arrangement as shown in the diagram. Before starting the experiment, we have seen the observation. We have all taken the list counts of devices which we are going to use. Now this is the observation table number 1, which is the longer one and the important one, because after getting this observation table only we will get the graph 1. So this is the graph 1. From graph 1 we have considered 5 points. From 5 points we have found this table. Okay, this table. Then we are having this graph number 2 from observation number 2. Similarly, we will draw graph number 3 from observation table number 2. So lastly we have seen what are the results of this experiment. So this is just about the Newton's law of cooling.